Okay, let's look at solving quadratic equations using the quadratic formula. The quadratic formula is just another way to get your solutions when you have an x squared equation. We've already looked at graphing, factoring, square roots, and completing the square. So this is the final method we're going to learn. So the quadratic formula is x equals negative b, that means the opposite of b, plus or minus, because you got to have those two roots, the square root of b squared minus 4ac all over 2a. The a, the b, and the c come from standard form of a quadratic equation, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant term. So make sure your equation is in standard form, equaling 0 before you start. So looking at number 1 here, we need to first identify a, b, and c because we're in standard form equaling 0. So a is the number multiplied to x squared, b is the number multiplied to x, and c is your constant term. So x is equal to negative b, which means the opposite of b. So if b is 2, that's negative 2. Plus or minus the square root of b squared, that's 2 squared, minus 4, times a, which is 1, times c, which is negative 63. You'll take this entire expression here and put it over 2 times a, which in this case is 2 times 1. Now what you need to do is figure out what the value of the number is under the radical. If it's positive, you're going to have 2 real solutions. If it's 0, you'll have 1 real solution, and if it's negative, you'll have 2 imaginary solutions. So going up here, we have 2 squared is 4, minus and a negative give you a positive, and then 4 times 63 times 1 is going to give us 252. When I add these two together, I get 256 is my solution. Now, 256 is a perfect square. So when I take the square root of 256, I'm getting 16. So I'm going to go down here to my quadratic formula, and I am going to replace my radical with positive 16. So now I have 2 expressions to solve. I have negative 2 plus 16 over 2, and I have negative 2 minus 16 over 2. That'll give me 14 over 2, which is 7, and negative 18 over 2, which is negative 9. So my 2 solutions are negative 9 and positive 7. On number 2, we have standard form equaling 0, so we're good. A is equal to 6, b is equal to negative 11, and c is equal to negative 10. So let's take those 3 values and plug those into the quadratic formula. First, we have negative b, which is the opposite of negative 11, so that's positive 11, plus or minus the square root of b squared, make sure you put that in parentheses, minus 4 times a, which is 6, times c, which is negative 10. All over 2 times a, which is 2 times 6. Now let's see what the value is under the radical. Negative 11 squared is 121. The minus times the negative gives me a plus. 4 times 6 is 24, and 24 times 10 is 240. Now we'll add these two together and we'll get 361. 361 is also a perfect square. The square root of 361 is 19. So we'll replace the radical with 19, giving me my 2 expressions, 11 plus 19 over 12, and 11 minus 19 over 12. So that'll be 30 over 12, which reduces by 6, and negative 8 over 12, which reduces by 4. So my 2 solutions are negative 2/3 and positive 5/2. On number 3, the first thing I notice is that it's not in standard form. So let's subtract 1 from both sides, and now it's in standard form equaling 0. A is equal to negative 1, b is equal to 2, and c is equal to negative 1. So x is equal to negative b, or the opposite of b is negative 2, plus or minus the square root of b squared minus 4 times A times C, all over 2 times A. So let's go under our radical. 2 times 2 is 4. A minus and 2 negatives make a negative. And then 4 times 1 is 4. So we get the square root of 0, which is 0. When the number under the radical is 0, you're going to have one real solution to this problem. See, you've got negative 2 plus 0 over negative 2. And then you've got negative 2 minus 0 over negative 2. You're getting 1 no matter how you look at it. So your solution here is positive 1. You have one real solution when the discriminant is equal to 0. Okay, on this one, let's subtract 4x from both sides to get negative 2x squared minus x equals negative 15. And then we'll add 15 to both sides to get negative 2x squared minus x plus 15 is equal to 0. So A is negative 2, B is negative 1, and C is 15. Negative B is the opposite of negative 1, which is 1, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A, or 2 times negative 2. So let's see what's happening under the radical sign this time. So negative 1 squared is 1. 2 negatives make a positive. 15 times 2 is 30, times 4 is 120. So when I add those together, I get 121, and the square root of 121 is 11. So I have 1 plus or minus 11 over negative 4. So that'll be 1 plus 11 over negative 4, and 1 minus 11 over negative 4. 12 over negative 4 is negative 3. Negative 10 over negative 4 reduces to positive 5 halves. So my solution set is x equals negative 3 and positive 5 halves. Looking at number 5, let's subtract 24 from both sides, and that'll give me 9x squared minus 25 equals 0. Now, in the past, we have factored this as a difference of two squares and solved the equations. We've moved 25 to the right and divided by 9 and taken the square root. So the quadratic formula is just another way to solve the exact same thing. So here I know that A is 9, B is 0 because there's not an x term, and C is negative 25. So x equals negative B. You can't find the opposite of 0. Plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. So looking under the radicals, 0 squared is 0, minus and a negative is a plus, and we're going to have 36 times 25, that's going to be 900. Because actually it would have been easier to do 25 times 4 is 100 times 9. So we get the square root of 900, which is 30. Okay, so that's going to be 0 plus 30 over 18 and 0 minus 30 over 18. 6 will go into 30 5 times and into 18 3 times. And then down here we have negative 30 over 18, giving us negative 5/3. So my solution set is negative 5/3 and positive 5/3. Number 6, let's subtract 10x, and we'll get 8x squared minus 10x. Now we've solved a problem like this in the past by factoring out a greatest common factor and solving those two equations when we're finished. We can also now use the quadratic formula. A is 8, B is negative 10, and C is 0 because we don't have a constant term. So negative B is the opposite of B, which is positive 10, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. So right here, when you multiply these three together, that will give you a 0. So you're going to have the square root of 100, which is 10. So we'll have 10 plus 10 over 16, and we'll have 10 minus 10 over 16. That's going to give us 20 over 16, which reduces by 5. This is by 4. This will be 0 over 16, which is 0. So x is equal to 0 and positive 5/4. Okay, now looking on the back, let's go ahead and look at number 7. Subtract 4x from both sides. Put it in order, x squared minus 4x minus 9. So here a is 1, b is negative 4, and c is negative 9. So x is equal to negative b, or the opposite of b, plus or minus the square root of b squared, put it in parentheses, minus 4 times a times c, all over 2 times a. So looking at this right here, we're going to have negative 4 squared is 16, minus and a negative is a plus, 36. So we're going to have the square root of 52. Now we know the square root of 52 is not a perfect square. So what we are going to look for is a way to simplify it. I know that 4 times 13 is equal to 52. So the square root of 4 is 2, and the 13 will stay under the radical. So I have 4 plus or minus 2 square roots of 13 over 2. Now simplify each part by 2. So I'm going to simplify this first part right here. That'll be 4 over 2 is 2. And now I'm going to simplify the second fraction. Let me find another highlighter here. And I'll do 2 over 2. Because you have to do both terms in order to divide by 2. So 2 divided by 2 is 1. That'll give me 1 square root of 13. So my solution set here is x equals 2 plus or minus the square root of 13. Now, looking at these, 8, 9, and 10 is more of the same. But when you get down to number 11, we have a is negative 3, b is 8, and c is negative 7. So x is equal to negative b, which will be negative 8, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So as I simplify my radical, that's 64, 3 negatives make a negative, 4 times 3 is 12, and 12 times 7 is 84. 6 minus 84 is going to give me a negative 76. So when you have a negative 76, certain things should come to mind here. Oh, excuse me, that's 8 times 8 is 64. So that's going to give us a negative 20. Okay, so if you have a negative under the radical, what's going to come to mind here is an imaginary unit. So let's simplify 20 into 4 times 5. The square root of 4 is 2, and the 5 stays behind. The negative sign will come out as a unit of I. So what we have here is negative 8 plus or minus 2i square roots of 5 over negative 6. So to simplify this, looking at your first fraction, you have negative 8 over negative 6. That's going to give me positive 4/3. Now looking at the second direction, you have positive 2 over negative 6 and negative 2 over negative 6. That'll just stay positive and negative. And then 2 into 2 one time, that'll give me 1i, and then 2 into 6 3 times. So we get x is equal to 4 plus or minus I square roots of 5 over 3. Now what that tells me is that this parabola will not touch the x-axis because you have two solutions, yes, but they're both imaginary.